There we go. This is being spastic. There are rules for adding them up, but they're actually pretty simple. If they are in series, we already know this rule, and I didn't know. I just threw it out there. Okay, but R in series, okay, is just R1 plus R2 plus R3 if they are one and then the other, and the other, and that's because one current goes through all of them, and so resistance at any point in the circuit just adds up. It's a cumulative thing, right? It's got to go through each single resistor. Okay, but if you have resistors in parallel, it's a different situation, right? So let's make a formula, right? Here's R1, and here is R2, and here is C3PO. No, just kidding. Right, and then this is some voltage V, right? Well, we understand, we've done enough of these problems, we've done 2 of them, or 3 of them, right? Okay, we've done enough of these problems that we understand that the total current leaving the battery is the sum of all those currents, correct? Right? So the resistance of this circuit is going to be the voltage divided by the total current, yeah? I1 plus I2 plus I3 in this case, right? Okay, and so that's going to be, really it's going to be that voltage divided by V over R1 plus V over R2 plus V over R3. Isn't that right? Yeah? And so I can divide the top and bottom by V, and I'll get the notion that it's 1 over R1 plus 1 over R2 plus 1 over R3. Now, the IB gives us this formula this way. 1 over R equals 1 over R1 plus 1 over R2. Okay? Those are ones. Yeah? That's the way they give it to you. But almost always you're trying to calculate the resistance. And so you almost always want to do it in this form. Okay? So let's take a look. Let's suppose we have a 5 and a 7 ohm resistor, right? 5 ohms, 7 ohms, right? And we want to find the resistance of it. Well, here's a little thing. The resistance of the 5 and the 7 is one of these rules, right? It's going to be less than the least resistor. It's always less than the least resistor, and here's why. We take the least one. If it's all by itself, a certain amount of current flows, but if you add another resistor in parallel, more current flows. Therefore, the circuit has less resistance to current. Yeah? Okay? And this one's easy. This one is going to be just 1 over, the resistance is 1 over 5 plus 1 over 7. And you're going to do this like 5 billion times from here to the end of the chapter. So the way you type this into your calculator is 5 to the minus 1 plus 7 to the minus 1 to the minus 1. Use the little minus 1 function. Okay? Now, if it's not a first function on your calculator, you can also type 1 divided by parenthesis 1 divided by 5 plus 1 over 7, right parenthesis. Okay? Either one works, but try that right now. Take your calculator right now and either use the reciprocal thing. See, my calculator here, it's a second function, so I'm going to use the 1 over. But I think your TI-83s, it's a first function. Isn't x to the minus 1 a first function? Yeah, there you go. So I'm doing 1 divided by 5 plus 1 divided by 7. 2.916666666. Is that what it is? There you go. Notice that it is, as we predicted, less than the smallest resistor. And if you ever get something that's bigger than any of the resistors, you did something wrong, because there it is, right? So again, the reason why it's getting less and less as you add resistors is that every resistor is an additional path for current in a parallel circuit, and so therefore allows more current to flow. Therefore, the whole circuit is less resistive, yeah? Let's try that. Figure that one out. Put this one on a whiteboard. These are quick and easy. Just put them on the whiteboard and show me. So 220 and 900, what is it? Yeah, that's right. What units? I can't read that. What does that say? That's right. Yeah, that's right. Whiteboard, whiteboard, whiteboard. Yeah, that's right. That's right. Whiteboard, whiteboard. That's right. That's right. You got it. The blood drive. Just want a little bit of your blood. They like asked me not to donate at one point. I faint. That's right. I'm a fainter. I passed that on to my daughter. That's right. Yeah, not the sight. I faint when people stick needles in me, and I think about it. That's right.
Does that mean if you think you got it right now?
I might. Yeah. Highly suggestible. There you go. Are we good? Has everybody gotten 177? Oh my God, try that one. Quick, quick, quick. I want to get to the interesting ones. Quick, quick.
Which one should we write down articles, all three of those, or just the one over?
It doesn't matter. This is the one you're going to have on a test. Yeah. Yeah, that's right. Yeah, you got it. That's right. Yep. There you go. There you go. There you go. Did everybody get 3.7? Let's try another one. 2 12s. Everybody's like, there it is. Is this surprising? Did you guys get 6 even? Yeah, 2 12-ohm resistors are going to let twice as much current flow as one 12-ohm resistor. Therefore, it will have half the resistance, correct?
Sure.
What about 324s? It'll let 3 times as much current flow as one 24-ohm resistor. Therefore, it will be 1/3 the resistance, and it will have a resistance of 8. Look for this on IB exams. They'll tend to give you things that come out exact like that, right? And it's a shortcut, right? So it's, there it is, right? Okay. So let's do this is an exciting one. Okay, now, is that series or parallel? It's serial or paries. What can you do? Now we're starting to work on the next. Series and parallel circuits are our atoms of understanding. This is the molecule of understanding. How should we proceed here?
Hey, I got it.
Start with the parallel. I don't know why that is, but yeah, you definitely want to start with parallel because that's the only place to start. You can't say that the 5 and the 16 and the 12 are in series because there's this other branch there, and series circuits don't have branches like that, correct? Yeah? So 16 and 16 is, no, but in parallel it's, what are they? 16 and 16 in parallel is what? 8. Now you've got a 5, an 8, and a 12. Can I have everybody's attention here? This is crucially important. So we take the 16 and the 16 and we condense them down to one resistor. Now in our mind, all of that nasty parallelness has been condensed to one resistor. It is an 8-ohm resistor. Are you picturing it? It doesn't have a branch in it. It's just 5, 8, and 12. That's easy.